So let's see some example which is given for the solving. In this graph you have to find whether it contains a Eulerian path or Eulerian circuit using the theorem. So that we see in two theorems we see. So this is also exercise. Under what condition KMN complete bipartite graph will have an Eulerian circuit? So this is also for solving. So you know that complete bipartite graph. In case of complete bipartite graph, there are two vertices set V1 and V2, and if it is complete, then there is a edge from each and every vertex of the V1 set to the each and every edge of V2 set, and total number of edges in case of complete bipartite graph is L into N. So if you know the condition for the Eulerian path, here they ask about the Eulerian circuit, and in case of Eulerian circuit, we know that degree of each and every vertex will be even. That is the condition for existence of Eulerian circuit in the given graph. So case 1, M is equal to N. In that case, both are even. If both are even and M is equal to N, suppose you take a vertex set V1 contain two vertices, and vertex set V2 also contain two vertices. In that case, degree of each vertex will be 2. So Eulerian circuit will be present. Then M is equal to N and both are odd. In this case, if you see, degree of each vertex will be odd if you consider the three vertices in each vertex set. So circuit will not present. M is not equal to N and both are even. In this case, both are even. So suppose 2 and 4, two vertices is vertex set V1 and 4 vertex in vertex set V2, and it is a complete bipartite graph. So degree of each vertex is even, so Eulerian circuit will be present. M is not equal to N for condition, case 4, M is not equal to N and 1 is even and 1 is odd. If 1 is even and 1 is odd, in that case it is a complete bipartite graph. So vertex set which contain odd number of vertices, that is considered in first set there are 2 vertices and in second set there are 3 vertices. Then in vertex set V2, each vertex will have a even degree, but in vertex set V1 each vertex will have an odd degree. So because of that, it will not contain a Eulerian circuit. Now next type of path and circuit is Hamilton path and Hamilton circuit. So a path is connected in a connected graph. G is a Hamilton path if it visit every vertex G exactly once. Means in case of Eulerian path, we seen that each and every edge should be visited exactly once. Then it is called as a Hamilton path. But here, Eulerian path. And in case of Hamilton path, path should visit every vertex G exactly once. So if you see this is the graph, and this graph is given. Path is given A, B, C, E, D. A, B, C, E, D. So in this path, each and every vertex is visited exactly once. So this path, that is A, B, C, E, D, we can call it as a Hamilton path. But if you in second case, C, B, A, D, E. Okay, this is also the Hamilton path as each and every vertex is visited exactly once. Then a circuit, now Hamilton circuit, a circuit in a connected graph G is called as a Hamilton circuit if it visits every vertex of graph G exactly once. So circuit means Hamilton path is called as a circuit if it visited every vertex of the graph exactly once. But in this case, E, C, B, A, D, E. Exception is of a starting and ending vertex, because we know that in case of circuit, starting and ending vertex is same. So starting and ending vertex will obviously repeat once. But in between vertex, if you see, there is no any repetition of the vertex, then it is called as a Hamilton circuit. Now there are some theorem which is derived for checking the given graph contain Hamilton path or not and Hamilton circuit or not. So let's see that theorem. Theorem 1: if the sum of degree for each pair of vertex is greater than equal to n minus 1, then there exists a Hamilton path. So this theorem is to check whether the given graph is containing Hamilton path or not. So what they said: if the sum of the degree for each pair of vertex is greater than equal to n minus 1, n means total number of vertex from the given graph. So if pair of any pair if you take from the graph and its sum of the degree of that vertex is greater than or equal to n minus 1, then Hamilton path will be existing. So we'll check this by some example later on. Theorem 2 says that if the degree of each vertex in G, that is degree of each vertex is greater than equal to n by 2, then G will contain the Hamilton circuit. N is nothing but total number of vertex from the given graph. And if the degree of any vertex, or we can say each vertex, not any vertex, each vertex is greater than equal to n by 2, then it is called as it contains the Hamilton circuit. Now these are the some example given. So here if you see, what is the condition for Hamilton path? So degree of sum of the degree of vertex is greater than equal to n minus 1. So take a simple example, this one example. So here there are 3, 4, 5, 6, 7, 8 vertices are there. So n value is nothing but 8. Okay. So and sum of the degree of each and every vertex should be greater than or equal to n minus 1. So n value is nothing but 8. Now degree of vertex C is 2, degree of vertex B is 3, 2 plus 3 5, degree of vertex A is 3, 5 plus 3 8, degree of F is 3, so 11, 8 plus 3 11, then degree of G is again 3, 11 plus 3 14, H again 3, 14 plus 3 17, and degree of E is nothing but 1 2 3 4 5 6 6, so 14 plus 6, that is 20, and this 3, degree of D, 20 plus 3 is 23. So it is obviously greater than sum of the degree of each pair of vertex is greater than equal to n minus 1. Therefore there is the existence of Hamilton path in this graph. Hamilton circuit के लिए what is the condition? Degree of any vertex or degree of each vertex is greater than equal to n by 2. So in this case, what is the value of n? N value is 8. N by 2 means 4. And if you see here, degree of C is 2. So 2 is not greater than equal to n by 2. So Hamilton circuit will not be exist in this graph. Find a Hamilton path and Hamilton circuit in A4, 3. Okay. So it is is a bipartite graph in which vertex at V1 contain the 4 number of vertices and vertex at V2 contain 3 number of vertices. So it has a Hamilton path. Here Hamilton path is exist or not, and Hamilton circuit is exist or not. You have to find. So what is the condition for Hamilton path? In case of Hamilton path, they said that sum of the degree of each vertex should be greater than equal to n minus 1. So in this case, n value is 4 plus 3, that is nothing but 7. Right. So Hamilton path is 7, minus 1 is 6, and degree of each vertex greater than the sum of the degree of each vertex is greater than n minus 1. This condition will be satisfied obviously if you sum the degree of each and every vertex from this bipartite graph. But Hamilton circuit, what is the condition? Degree of every vertex, each vertex is greater than equal to n by 2. N by 2 means in this case 7 by 2, that is 3.5. And degree of each vertex, if you see 4, 3, okay. It is not greater than equal to n by 2 because n by 2 is 3.5, and here we will get a degree of some vertices as a 3. So it is not a greater than condition, means 3.5. So because of that, Hamilton circuit will not exist. This is all about paths in the graph. So we've seen what is meant by path, then we've seen simple path, then elementary path, then we've seen Taylorian path and circuit, then we've seen Hamilton path and circuit, and after that we've seen some theorem which is used to check whether the given graph contains Taylorian path and Taylorian circuit and Hamilton path and Hamilton circuit. So it is all about this lecture. Thank you.